A 900 picofarad capacitor is charged by 100-volt battery. How much electrostatic energy is stored by the capacitor? And the capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. What is the electrostatic energy stored by the system? Where has the remainder of the energy gone? First, let's solve one by one. Try to draw the circuit diagram for the given the first case. So for the first case, given that a 900 picofarad capacitor, suppose if this is a parallel plate capacitor, it is connected to a potential source. So potential source is a battery. Now its capacitance is given, it is 900 picofarad. So that's the value we know. Capacitance C equal to 900 picofarad, which equal to 900 times 10 power minus 12 farad. And one more value which is given, potential V equal to 100 volt. So now here the potential V equal to voltage equal to 100 volt. Now I would like to know what is the charge on the capacitor plate. The charge on the capacitor plate. To find out the charge, you can use this relation. Capacitance of a capacitor C equal to Q upon V. Therefore, Q equal to C times V. So this relation you can find that C equal to Q by V. Now if you find the charge Q equal to, just multiply the two terms. Capacitance is 900 pico 10 power minus 12 farad times potential is 100 volt. Now capacitance Q equal to 9 times 10 power 4, these two positive zeros, times 10 power minus 12 charges coulomb. Now Q equal to 9 times 10 power minus 8 coulombs. So the charge on these two plates, which equal to 9 times 10 power minus 8 coulombs. So for the moment I would like to call that charge at here, this is positive charge, this is plus Q and this is minus Q. Now if you know the charge on the plate, now our task is to find the energy stored. The energy stored, energy stored in a capacitor. In a capacitor, you can take the formula energy, potential energy U equal to half CV square, potential energy U equal to half CV square, because we know the capacitance of a capacitor and we know the potential. Now if you can substitute those values at here, so I can get that potential U equal to half, capacitance is given that 900 pico, pico means 10 power minus 12 times potential is 100 volt, it means 100 square. Now let us simplify this, it will becomes potential energy U equal to half in 9 is equal to 4.5. So 4.5 times, here the two zeros are there, I will write the 10 square times 10 power minus 12 already is there, and 100 square you can get 10 power 4. So potential energy stored in a capacitor 4.5 times 10 power minus 6, energy is joules. So this is the amount of the potential energy. which is stored in that capacitor. So that is the first part. For the second part, now that capacitor which is already having charge plus Q, this is positive charge and this is negative charge, is connected to a uncharged capacitor. This is uncharged capacitor. So when you connect a charged capacitor to uncharged capacitor, what happens? Since it is uncharged, in this there is no charges. The tendency of the charges is that so they have to move from higher potential to lower potential. Now this diagram will be changes to me. Now the charge will be flow from one capacitor to another capacitor and the charge gets quantized. So after flowing the charge, let me take this as a new charge plus Q dash and minus Q dash, and the same charge also will be present in the second capacitor. It means the amount of the charge gets half in the both of the cases. Now this is the new charge after connecting with the uncharged capacitor. Now we need to find what is the new charge and also we need to find that what is the new energy stored. To find that, first I need to write what are the changes happens. The changes are first the change in the potential energy. So the first change in potential energy. How it is? If you remember this formula, capacitance C equal to Q by V. Now, after combining uncharged, automatically the charge is reduced. The Q will be changed. If the Q will be changed, obviously there is a change in the potential, but capacitance should be remains same. So that is the first change we can able to observe. So the change in potential, let me take the change in potential as V dash. What is the second change? The second point, there is a change in the charge. So how much change is taking place? The charge gets half. So if you can take that new charge Q dash equal to C times V dash, because potential remains constant. Now to find out the total energy of system, therefore the total energy of the system, here the energy means potential energy only. The total energy of the system equal to, so potential energy formula, if you can take that, potential energy U is equal to half QV. So here I am having the two capacitors, I can write that half, each capacitor having the charge Q dash and the new potential V dash, plus half charge Q dash and the potential V dash. Why here I have taken the potential V dash? Since they are connected in such a way that parallel combination, so in the parallel combination the potential remains constant. So that is the total energy. Now if you can write that total energy, the total energy of the system, just you can add up these two and these two will becomes Q dash times V dash. Now for the further simplification, if we can take that, since q dash equal to, or I can remember like this, it is very easy to me, capacitance C equal to q dash by V dash, that implies q dash equal to C times V dash. Or if we can write in terms of V dash, since it's easy to change V dash value, we can change that V dash. V dash equal to q dash by C. So if you can substitute this value at here, now the new energy gets changes as q dash times q dash by C. Now since q dash equal to q by 2, since q dash equal to q by 2, if you can substitute that value at here becomes q by 2 times q by 2 upon C. Now that will becomes q square by 4C. q square by 4C. Therefore, the new energy of the system is equal to q square by 4C. But in the system, after combination, we don't know what is the q dash and what is the new charge and what is the new capacitance. For that, if we can manipulate this above equation, I would like to write that half times half q square by C. I wish I would like to write like this. Since we know that this value half q square by C value from the above equation, from the first equation we can get that, and we solve that expression also. We solve that expression, potential energy U equal to half CV square. So from this expression we can get the same, half QV. Now if we can substitute that value at here, now I can get the result that which equal to half times, and that value is got it as 4.5 times 10 power minus 6 joules. Now if you can further simplification, it 2 gets cancelled in 4.5 equal to 2.25. Therefore the energy stored in the system of two capacitors, which equal to the energy stored in the system of two capacitors equal to how much it is? It is 2.25 times 10 power minus 6 joules. See, now here the energy value is decreased. When a single capacitor is connected, the energy value equal to 4.5. When single capacitor is connected and the energy value, so this is the energy value is 4.5. But when the two capacitors are connected, the uncharged capacitor is connected to a charged capacitor. Now the energy value is decreased. It means half of the value is decreased. Now the third question, where the difference in the energy is gone. If I write the difference in energy for the third question, energy difference equal to 4.5 times 10 power minus 6 joules minus 2.25 times 10 power minus 6 joules. So the difference in energy equal to 2.25 times 10 power minus 6 joules. So this is the energy difference. And the question is, and this much energy is gone where? And in the parallel combination of the capacitors, when they connect in the parallel, due to because of the charge redistribution, energy gets lost. So this is the lost energy lost. The energy lost is in the form of either radiation or heat, or in the mostly the electromagnetic radiation, or the energy lost is in the form of the heat. So that's the reason, because of the redistribution of the charges. One thing I want to say that, so in the place of half q square by c, I have taken directly this value from the above expression, from the first expression which I solved in the earlier. But if you notice that here I solved it for half cv square. So here I have taken and solved that half cv square. So this is one of the important. Here I solved that half cv square, but c equal to q by v. If you can substitute that value there, that becomes half q by v times v square, and v gets cancelled, which equal to half qv. So I want to say that this half cv square and half qv, they both are same. Don't think that. So how did I get it the value at here? I solve at here half cv square. In this expression half cv square, this is the expression half cv square, 4.5 into 10 power minus 6 joule, and I substitute that expressions directly at here. So this is the expression in the place of half q square by c I substituted. So how did we get? We can convert this expression in terms of half cv square. So better I do it here for your understanding. Later I can do that. I wish I would like to manipulate that half times q equal to cv, and here you can substitute that c square v square by c. So 1 c gets cancelled, it will becomes half times again half c v square. Now I think it's okay. Now we got it half cv square from the first expression. So this is the expression for half cv square, and that value if you can substitute, and if you can substitute that value at here, we will end up with the same. There was that. Yeah, here it is. So I can end up that half times 4.5 times 10 power minus 6 joules, and this 4.5 and half can cancel, 2.25. It end up with the same. So finally, so this model says about that when uncharged capacitor is connected to a charged capacitor, first the charge distribution takes place, and second, energy gets lost. That loss in the energy is in the form of heat or electromagnetic radiation.